Okay, so you've got to hear this. I came across a research paper that is, well, it's absolutely jaw-dropping. We're talking about an AI that can basically dream up a model of the physical world. And this dream, it's so accurate it can predict what's going to happen in real life. This is a huge leap forward for sure.
You know those videos that are all over the internet, right? The robots doing parkour, the insane backflips, the dance moves. It feels like we're living in the future. But what if I told you that all that stuff, all that fancy footwork, that's actually the easy part for a robot?
Yeah, seriously. Those impressive demos, they all happen in these perfect, sterile lab environments. Every single step is planned out. But the real challenge, the stuff that's actually super hard for robots, it's the boring, messy, everyday stuff. Like trying to fold a t-shirt, dealing with weird objects, different surfaces, a cluttered room. That's the stuff that's been basically impossible for them.
So how do researchers even begin to tackle this? Well, the standard way is to train the robot inside a computer simulation first. Kind of like a pilot in a flight simulator, right? It's a safe space to learn and make mistakes. But there's a massive, massive problem with this approach.
This is what people in the field call the sim-to-real gap. So inside its perfect little digital world, the robot is a genius. It performs flawlessly. But the second you take that programming and put it into a real robot, in the messy, unpredictable real world, everything just falls apart. And I mean, it fails spectacularly. This has been a huge wall stopping progress for a long, long time.
And here's the reason why. The simulators themselves are the bottleneck. See, they're built on these really complex, handwritten physics equations, which, okay, on one hand, that makes them super precise, but on the other, they are painfully slow. And even worse, they're brittle. What that means is, if you change anything, like the robot's arm shape or the texture of a surface, the whole thing breaks, and some poor engineer has to go back and manually retune the code. It's just not scalable.
Okay, but what if you could just throw all those equations out the window? What if an AI could learn physics just by watching? Like it just watches videos of the world and figures out how things are supposed to work on its own. Well, that's the wild idea behind this brand new AI.
And they gave it the perfect name, of course, NERD. It stands for Neural Robot Dynamics. So instead of calculating physics with all those rigid old-school equations, NERD learns the rules. It's less like a calculator and more like a brain that develops an intuition for physics just from observation. It literally creates its own internal simulation, its own dream of how the world works.
So let's just recap. The old way, it's all about those rigid, hand-coded equations. Sure, they're precise, but they are slow and super brittle.
And then there's the nerd way. It flips that whole idea on its head. It learns by watching, and that makes it incredibly fast and way more adaptable. No more manual reprogramming.
All right, that all sounds amazing in theory, right? But does it actually work? Can a robot trained inside an AI's imagination function in the real world? Well, the researchers put it to the test, and this is where things get, well, honestly, a little mind-blowing.
So check this out. On the left, you've got this blue spider robot. It's walking around in a standard, high-quality physics simulator. But the orange one on the right, it learned how to walk entirely inside NERD's AI dream world. And here's the kicker. They took what it learned in that dream and dropped it into the standard simulator, and it just worked perfectly.
Okay, but that's still just a simulation talking to another simulation. It's still a video game. The real test, the ultimate test, is taking this to the physical world. So they trained a real robot arm entirely in NERD's imagination and then set it loose in reality. This is the moment where, historically, everything goes wrong. And the task was pretty simple. Just touch the red dots.
And here's the breakthrough. It didn't just work. It got a 95% success rate. It makes it look easy, but trust me, for anyone who works in robotics, this is anything but easy. This is a massive, massive leap across that sim-to-real gap we were talking about.
So you're probably thinking what I'm thinking. How? How is this even possible? How can an AI's dream be so good that it prepares a robot for the real world? Well, the answer comes from one last, really incredible experiment. Okay, so what they did was, they took real video footage of someone tossing a cube. Then, they asked both the original hand-coded physics simulator and the NERD AI to predict where the cube would land. And, get this, after NERD got to see a little bit of the real-world data, its prediction wasn't just good, it was more accurate than the original simulator that it learned from. The student literally became the master.
So, why? How did that happen? Well, think of it like this. The traditional simulator is book smart. It knows all the perfect, idealized equations from a textbook. But nerd? It's street smart. It's the one that actually went outside, saw how things really work, felt the friction, saw the little imperfections. It learned from the messiness of the real world. It has practical experience.
And that right there is the heart of this whole thing. The future of robotics isn't just book smart, it's street smart. By learning from data instead of being programmed with rigid equations, we can finally build AIs that have a real, intuitive feel for the world. This just cracks the door wide open for a whole new generation of robots. So, let's break down the big takeaways here. First, Nerd seems to finally bridge that frustrating sim-to-real gap. Second, it is so much faster and more adaptable than the old ways. And third, it lets robots build up this kind of intuitive, street-smart feel for physics, which was just impossible before.
Look, this is a total game changer. It's going to help us build much more capable robots that can actually help us out in our homes or explore places we can't go. But it also leaves us with this one kind of crazy thought to chew on. If an AI can learn the fundamental laws of physics just by watching, what else can it learn?